Hello, this is the 10.2 through 10.4 conics section extension. One of the conics sections that this book puts before the 10.2 to 10.4 is circles. And we haven't talked about circles yet, but circles are a conic section, a lot like ellipsoids. And I usually do this on Pi Day. You'll notice it says Pi Day circle stuff. Usually get to have pi. So make sure while you're doing this section, you get a great big chunk of pie, and you go through this with me. So the first part will be some notes. The second part will be, there's two sheets here that I want you to do. So you're going to be responsible for the first 3 pages. Pages 4 and 5 you can do for extra credit. They're harder problems. There's some application problems. And if you can get to those, that's great. But we're going to be responsible for the first 3 pages. When you're done filling out the first 3 pages, you'll submit those online. You can either print this out if you want to, or you can go and download it on Notability and then submit it that way. I don't care. I'll take either way. So first of all, some formulas. And these formulas are right off the ACT, some of them. And some of them are pre-calculus based. So let's look at them. So we have circumference, area, arc length, and area of a sector. We know circumference 2 pi r, we know area pi r squared. Arc length, you actually just take the 2 pi r and you multiply it by however many degrees you have divided by 360. And what arc length is, it's like how far is it from point to point around the outside of a circle. And area of a sector is kind of the same concept. You take pi r squared times the arc degrees over 360. And what you're looking for on that one is like how much is that piece of pizza, how many square inches of that piece of pizza. So arc length is like a units measurement, and area of a sector is like a units squared measurement. And they have a couple of different formulas. Area of a circle centered at the origin is x plus y squared equals r squared. And if you move that origin, if you take it and it's centered and you actually like do the slide, you introduce that idea that we've seen before of h and k. H associated with the x, k associated with the y, and you can plug in the h and the k over there with the r squared, and that's the basic general formula. I have seen this a ton on the ACT. This appears all the time. It's not too hard. A little bit of circle vocab. Radius, we know. Center out. Radius. Diameter, we know. Through the center. The entire length. Diameter. A chord is a little different. A chord starts on one spot and it goes across the circle. It doesn't necessarily go through the center. That's a chord. A tangent to the circle is not like tangent from trig. It is just simply a line that comes. It's almost like a rock skipping off the water. If you've ever skipped rocks, it kind of comes in, it boom, and then it keeps going. That's kind of how a tangent works. That little point right there is called the point of tangency. And this is the tangent right here. And the last one is a secant. And a secant is something that comes through and it pierces it. It's similar to a chord in that it hits twice, but a secant hits twice and keeps going. So that's a secant. Common vocab that we're going to use in this section. And really what we want to know is when we're looking at an equation, or if we get to an equation, what is it that makes a circle a circle? And you're going to check for x squared and y squared. We've seen this before. Remember, if one of them was squared, if it was just the x squared, it would be a parabola. If it was x squared and y squared and there was a plus sign or a minus sign, it was elliptical or hyperbola. Well, this one, we check for x squared and y squared. We check the leading coefficients of x squared and y squared. Are they the same? Then they're a circle. And are both x squared and y squared is positive? So this right here will kind of give us a little bit of background if we're looking at the general form of an equation. Is it a circle? Is it an ellipse? Is it an hyperbola? And I'll show you some of that example stuff later. So now, that's kind of your notes. Now I'm going to actually do circle problems. And some of these will be very geometric based. Some of these will be not geometric at all, and more conic section. I think it's a good practice. It's been a long time since you've dealt with circles, probably all the way since geometry. Some of these I'm going to get you part way to the answer, and then you'll be responsible for finishing off the problem and then handing that in. So here we go. It says write the equation of a circle with radius 6 centered at the origin. I'm going to go from a picture format, 0, 0, that would be your H and your K, and 1, 2, 3, 4, 5, 6. We're looking at the equation of that. Also, as we do these, you should have Desmos out, and when we're done writing the equation, you should plug it into Desmos. I will be telling you to do that. It would be helpful to have a second device out with Desmos popped up. All right, so radius is 6. There's my R is 6. Centered at the origin, really easy. X squared plus y squared equals 6 squared. It would be written as x squared plus y squared equals 36. And you can plug that right into Desmos right now. Hit pause, look at the graph, look at the picture, and we should have this scenario. All right, write the equation of a circle with radius 5 root 3 centered at -2, 5. I'm going to draw a picture again. Centered at -2, 1, 2, up 1, 2, 3, 4, 5. So here it's centered. And now it's 5 radical 3. And 5 radical 3 has some decimal associated with it. But it really doesn't matter what that decimal looks like. It's going to be a circle like that. HK is -2, 5. You should be able to write the equation. X minus the H value. The H value is -2 squared plus y minus the K value, which is 5 squared, is equal to the radius squared, which is 5 radical 3 squared. I want you to clean that up and write your answer down there. I'll be checking for that answer when I look at your work. Make sure you do 5 root 3 squared. If you don't know how to do that, just do it on the calculator. Make sure you use parentheses. Write the equation of a circle that contains points -2, 3, and 4, -10. This is one of the harder problems. This one I usually put on the chapter test. So I'm at -2 and up 1, 2, 3. And I'm at 4, -10, so 1, 2, 3, 4, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have a dot there, a -2, 3, a dot there. And what it says is these are endpoints of the diameter. So if I was to draw the diameter in, I would have a circle that looks something like this. Okay? And I want the equation of that. So a couple things. Number one, I don't know where the center is. Well, I kind of do. It's going to be in here somewhere, but without graph paper, I'm going to have to do something here. And then I don't know the radius either. But if I can find the center, I can find the radius. Or I could just take the diameter and divide it by 2 if I really wanted to. So what I will do here, bump that a little bit. What I'm going to do here is I'm going to find the midpoint of this diameter. If I could find that midpoint right in here, I would know the center of the circle. So the midpoint formula, add up the x's, divide by 2, add up the y's, divide by 2. For this problem, the x's are those two. -2 plus 4 is 2. 2 divided by 2 is 1. I'm going to add up these two. -10 over -10 plus 3 is -7. -7 over 2 is -3.5. That's the center of the circle. That's your H, and that's your K. Now that's a little funky. I don't really want to use that in the distance formula, so for the distance formula, I'm going to find the diameter with the distance formula from there to there, and I'm going to divide it in 2, so then that'll give me the radius. So the distance formula, the square root of x2 minus x1, I'll go 4 minus a -2 squared plus y2 minus y1, I'll do -10 minus 3 squared. And this should really take you back to geometry. We did a lot of distance formulas in geometry. Probably been that long since you've actually done this, though. That's 6 squared, which is 36, plus, well, that's -13 squared, which is 169. And I will square root that, and I also have a calculator here, so I'm going to use it. 36 plus 169. I got root 205. Okay, that's the diameter. Divided by 2 is the radius. We're ready to write the equation. It's going to look a little funky, but that's okay. X minus the H value. squared plus y minus the k value. The k value, I'm going to put plus 3.5 squared is equal to radius squared, which is that squared. And if I was to square the top, I get 205, and if I was to square the bottom, I would get 4. So I'm going to get 205 over 4. And what I would really like you to do here is press pause and plug that in. While you press pause to plug that in, I'm going to go check my answer sheet just to make sure I got it right. That's a funky number. I don't even know if I got it right. So plug that in. Let's see if we got it right. So when I did it, 205 over 4, I got 51.25, which I think is 205 over 4, so I think we're right. We're in good shape. All right, number 4, write the equation of the circle centered at 4, 5, and tangent to y equals -3. Centered at 1, 2, 3, 4, 1, 2, 3, 4, 5. So it's here. There's the center. And tangent to y equals -3. Now y equals -3 is a lazy line. 1, 2, 3, a lazy line down here. And if it's tangent, that means my circle is going to come like this. Like that. So, HK, and that distance right there, that's your radius. Well, if I'm over 4 and up 5, so that distance is 5, and this y equals -3 is down 3, that makes my radius 8. And you can write the equation 4, 5 with a radius of 8. Use the same formula that we've been using to write the equation of the conic section. You finish that one. A circle has a diameter, find the area and circumference. So, different type. Diameter given area and circumference. Definitely geometric, definitely one that appears on various types of problems, ACTs, SATs, whatever, especially when the radius here, the diameter here is weird. It's 3√10. So area of a circle, circumference of a circle. Circumference, 2 pi r, area pi r squared. I'm going to go ahead and find the radius. The radius would be 3 radical 10 over 2. And I'm just going to leave it like that. I guess I could write a 1.5 root 10 if I wanted to. But the circumference, 2 times pi times the radius, which is 3 radical 10 over 2. The 2's will wipe out, and I'll be left with 3 root 10 times pi. And that's actually the exact answer. That's what you would see on that ACT. Go ahead and find the decimal and write it out also. I'll be looking for that when I check your work. Also, I'm going to go pi. My radius squared is 3 radical 10 squared. And I guess let's do it. 3 radical 10 over 2 times 3 radical 10 over 2. 3 times 3 is 9. Root 10 times root 10 is 10. All over 2 times 2 is 4. That's the value, so that's 90 over 4. I guess I could pull the 2 out and get 45 over 2. It looks like that value is 45 over 2. So on a standardized test, it'd say 45 over 2 times the pi value. So it'd be 45 pi over 2. What is it in? It just says units. So that'd be units squared, and that would be units. Again, it does have a decimal associated with it. So you need to go in, find that decimal, and write it down. I'd like to see both of those 2 decimals right there on your paper when you go. That tells me you're actively involved in what we're doing here today. I'm not just sitting there like a slug. You've gotten up. You're ready to go. You've combed your hair. Boom. Let's go. All right. Next one. Circle has an area of 68 square centimeters. Find the circumference. Circumference given area. So area is pi r squared. We know the area is 68. I guess I should go in and find the radius, because if I can go in and I can find the radius, then I can use that to find the circumference. So I'll divide by pi, and my r squared value is 68 over pi. And the square root of that, the square root of 68 over pi. I think I'm going to go ahead and I'm going to find this one as a decimal. I could deal with that situation, but I'm just going to sweep it under the rug a little bit here. Let's go 68 divided by my pi value. 68 over pi, I got 4.65. So my radius is 4.65, and this is an approximation. I can go in and, now that I've found the radius, I can go in and find the circumference. You take that, plug it in, and find out your answer for circumference. Number 7, you should be hitting pause as I leave little things for you to do. Hit pause, do it, unpause it, go to the next question. All right, a pizza has 8 equally cut slices. Oh, what a bad pizza. If the pizza has a 20-inch diameter, well, that would mean the radius is 10. How many square inches of pizza do you get in one slice? So how big is that? Well, what this is, it's an area of a sector problem. So area of a sector, I usually put AS for area of the sector. It's the pi r squared, and then you take the arc degrees over 360. And what this arc degrees is really giving you over 360, it's giving you how much of the circle that you have. And I'm going to be able to I'm not going to have to use that because I can look at it and I can tell I have 1/8 of the circle. So I'm going to take the pi r squared, and then that's 1/8 of the circle. So I'll go pi, it said again, the 20-inch diameter, which means the radius is 10, squared times 1/8. And out of that, that's 100 over 8. And I still have the pi and reduced value, I don't know what, divide by 4. So 25 pi over 2. If I divided by 4 correctly, that would be, I don't know, square inches. And go ahead and crank out that decimal and write it down, find out how many square inches of pizza you have. All right, number 8, find the length of arc AB. Find the length of, in geometry, you'll see that little arc over here, so we want an arc length problem. So AL, you can get that formula from previous in this chapter, previous in this little note sheet. So it's 2 pi r, again, it's the arc over 360. And I'm going to use that arc right now. I don't know, you might know that that's 1/3 of the circle, 120 degrees if I'd have 120, but I'm going to go ahead and plug the 120 in right there. That 120 goes in for the arc degrees, and you can see that that's 1/3, and 2 pi, and my radius is 3. Go ahead and write down the exact value and the decimal approximation. I want to see 2 answers, one right there, and then the approximate decimal approximation right there. Go ahead and write both of those down. Likewise, find the arc length of ABC. ABC. Now, ABC with 3 letters tells you to go the long way. And I gave you 2 radians there. I didn't give you the whole thing. So I'm going to do this kind of from the chapter 4, the sine is y, cosine is x, tangent is y over x chapter. We're gonna use some of that information, and we're gonna find the length of the big one. So arc length is 2 pi r times the arc over 360. 2 pi r times arc over 360, and I'm going to take 2 times the pi value, and the radius is 5. But I got to know arc over 360, and maybe I'll adjust that, because really, how much of the circle is here? Well, if we think now, a whole circle in terms of radians, well, 1 full revolution is 2 pi radians, which would mean this little chunk right here, well, that would be 2 radians subtracted off of the whole revolution, so minus 2. That would be, the whole circle is 2 pi, and then that little chunk right here would give you, I guess instead of whole, I'll put, that's the blue part right there, the highlighted blue I have. And then I still need, like, what percentage is that of the whole? So I'm going to divide that by the whole revolution, which is 2 pi. And this fraction right here represents the blue chunk, the blue length. because I gave it to you like that. So I'm going to plug in here 2 pi minus 2, and then I'll divide it by 2 pi, and that should be a decimal under 1, and that decimal should equate to how much of the circle we really have. Why don't you go ahead and crank this one out as a decimal only? That math in there can kind of get crazy. Actually, not so bad. I see something. I don't know if you see it, but looky here. Oh, my favorite property, whap whap. Those are gone. And my answer would be that and that. My answer would be 10 pi minus 10 would be the length of that arc. And wow, that's pretty cool. I'm glad I saw that. All right, page 2, last page we have to do. We'll keep chugging away. A circle contains points. Find the circumference and the area. Again, these are endpoints of the diameter, so I'm going to draw a little picture, and I'm going to kind of draw it like this. This is the point 1, 1, and then 101, 101 puts it right up there. That's 101, comma 101. And this problem, those are endpoints of the diameter, which means the circle goes something like this, and that is the point 1, comma 1. And I'm going to attack this one from a little bit different. I'm not going to actually do the distance formula and the midpoint formula. This one wants us to find the circumference and the area. I'm going to find the diameter with the Pythagorean theorem. And then I can just use that diameter, cut it in half, and go from there. So if that's 1, 1, and that's 101, this is 100, and this is 100, which means the diameter is the hypotenuse of a 45, 45, 90 right triangle. There's my 45, 45, 90 right triangle, which means this is 100 radical 2. Okay, that makes my radius half of that, which is 50 radical 2. 50 radical 2. So I found the radius. You guys can go ahead and find the circumference and find the area right now. Use the formulas from before. Plug in 50 root 2, give me the exact answer, and give me the decimal approximation. A circle centered at the origin is tangent to the line x equals 7. Find the equation of the circle. X equals 7. 1, 2, 3, 4, 5, 6, 7. There it is. Centered at the origin. There's the center. Picture's going to look like that. You write the equation. Next one, write the equation of the unit circle. Okay, the unit circle, the prevailing characteristic is that that distance in the unit circle was 1. Write the equation. Which of the following are circles? X squared and y squared, both positive or both negative. Actually, it would work for both to be negative also. And they have the same leading coefficient. So let's look. X squared and y squared, both positive. X squared and y squared. X squared and y squared. They're both positive. They don't have the same leading coefficient, but they have the same denominator. I could multiply everything by 10, and we get it. X squared and y squared, okay, both positive. They were all circles. They were all circles. Okay. Next one. Here we go. Write the equation of the circle shown. Well, easy. There's the center. That distance is the radius. You do that and fill that in right there. Write the equation of the circle centered at 314 with a diameter of pi. I don't know. I was just trying to have fun with this one. I don't know if you see the humor in this, but I hope you do. 314 with a diameter of pi, that means 1, 2, 3, and then up 14, and the diameter of pi would make it a circle about like that. And now if the diameter is pi, that means the radius is pi over 2. And we'll go x minus h squared equals, or no, x minus h squared plus, that's a plus sign, plus y minus k squared equals the radius, which is pi over 2 squared. And I just wanted to write that up. Pi over 2 squared times, so pi over 2 times pi over 2 is pi squared over 4 is how you write that radius, and you can go from there. A circle, next one. A circle has an area given and is centered given. And what we need to do is we need to find each one of the following. So if I'm given area, 314.15, area is a pi r squared number. And divide by pi and square root it, and you'll find the radius. And then after you find the radius, you can find the circumference. You can find the equation, not faux, find the equation of the circle. And then I want you to take a little picture here. So it's centered at -5, 7. So you can draw your picture like this. Put your little dot. And then whatever you found for your radius, you can do that. Okay, it's time for the move of the day. And back to math. Here we go. Just a couple more. What fraction was used to denote pi? So this isn't even in this chapter. This is just stupid facts. So there were ancients, when they did all this math, all this Pythagorean theorem, all this stuff, they actually came up with a fraction that really comes close to approximating pi. And this is what they used before they figured out pi was irrational. And pi being irrational basically means that it's a decimal that goes on forever and ever and ever, and it never stops. It just keeps going. And they've actually proven this with giant computers where they've computed it. But anyway, the ratio is 22/7. And I want you to, right now on your calculator, do 22 divided by 7. And I want you to just write out the whole big long decimal in your calculator. That tells me again that you're engaged and you're doing what you should be doing. All right, next one. I got 2 more is all. How many revolutions does a tire make with a 20-inch radius make in a mile? So I'm trying to figure out. So if you have a tire and you drive a mile, like how many times does it, a 20-inch radius tire would be a typical car, but it goes around. How many times do you think it goes around? Like 100, 1,000? Doesn't matter how fast the car is going. I don't think it does. If you went a mile an hour or 100 miles an hour, unless you were squealing, the car would be the same. So I guess this is a circumference problem. So my circumference is 2 pi r, and it's got a 20-inch radius. So 2 times pi, and then my radius is 20. I don't think it makes a lot of sense to put 40 pi here. So what I'm going to do is I'm going to go ahead, make sure I'm right. I think so. So this is in inches too. I'm going to have to do a conversion here. 20 times pi times 2. So it goes for every time this thing goes around with 125.6637 inches. Well, I need to know how many inches are in a mile so I can figure this out. So I have 5,280 feet is 1 mile. 1 mile. And then I know 1 foot is 12 inches. So I can multiply those two together. 5,280 times 12. I got 63360. 63360 inches. And if I want to find out how many times this wheel that goes this far will hit the ground when going this far, well, divide those two and write down your answer. All right, and the last one. Last problem, find the area of the shaded region. So what I'd be looking for here is the area of this little yellow spot. And this was a problem I called the whole problem from the geometry. The yellow part, I would take the outer and I'd subtract off these inner circles minus the inner. So the outer is pretty easy. It's 12 times 12. But the inner part, the inner is is each one of these, and you might notice that all those circles are the same. Boy, if I knew the radius of a circle, then I would have it. So can you figure out what the radius of that circle is? Well, 12, so it would go 3, 3, 3, 3. That'd be 12 across. So the radius of each circle is 3. So what I'm going to do is I'm going to take the inner part. I have 4 circles. So I know I have 144 minus 4, and then each circle is pi r squared, which is pi 3 squared. And to end, what I would like you to do is I'd like you to evaluate this exactly, which means leave your pi in the answer. And I would also like the decimal approximation. When you're done with that, go ahead and save it, and you can upload it for your grade. We'll see you later.